So for question 7, part 1, we need to find the area of this trapezium here, a, b, c, d, and to give our answer in the form a plus b root 5, where a and b are integers. So to find the area of a trapezium, this is going to be the average of the lengths. So there's 6 plus 3 root 5 and the 2 plus 3 root 5. On the average of those two lengths there, times the vertical height, which is 10 minus 2 root 5. So we know this is the vertical height because we're told that angle ADC is 90 degrees. So working this out then, the average of our two lengths, that's going to be half of 6 plus 3 root 5 plus 2 plus 3 root 5 times the vertical height, which is 10 minus 2 root 5. So that is equal to half times, well, 6 plus 2 is 8, and then 3 root 5 plus 3 root 5 is 6 root 5, and then times 10 minus 2 times root 5. So for this first bracket here, well, if we have half of 8 plus 6 root 5, well, that is just going to equal 4 plus 3 root 5, and then times 10 minus 2 root 5, and then expanding that out. So we'll do the 4 times 10 first, so that's equal to 40, and then we'll do this 4 times minus 2 root 5, so that's going to be minus 8 root 5, and then we've got 3 root 5 times 10, so that is 30 root 5, and then 3 root 5 times minus 2 root 5, well, it's going to be minus 6 times, well, root 5 times root 5 is just 5, and then simplifying this down, we've got 40, and then we've got this minus 6 times 5 here, so 6 times 5 is 30, so 40 minus 30 is 10, and then we've got this minus 8 root 5 plus 30 root 5, and that is 22 root 5. So that's our area, and we can put the units in if we want. It's going to be in centimetres squared. So that is our final answer then, 10 plus 22 root 5 centimetres squared. So that is question 7, part 1. For part 2, we need to find the cotangent of BCD, and to give our answer in the form c plus d root 5, where c and d are fractions in their simplest form. So angle BCD, that's this angle in here. So to start with then, we'll draw a vertical line going down from B. So that means this part is 90 degrees, and this length here is 4, because it's the difference of these lengths here, 6 plus 3 root 5 and 2 plus 3 root 5. Okay, and we know the vertical height, so that dotted red line I've got there, that is 10 minus 2 root 5. So the cotangent of an angle, so we want the cotangent of BCD, well, that's going to be equal to the adjacent over the opposite, and in our case the adjacent is 4 and our opposite is 10 minus 2 root 5. So now we need to rationalize the denominator here, so we'll times top and bottom by the conjugate of the denominator, so that's going to be 10 plus 2 root 5. So this is going to equal then 4 times 10 plus 2 root 5, and that's going to be over 10 minus 2 root 5 times 10 plus 2 root 5. So this is going to equal, well, in the numerator we're going to have 4 times 10, which is 40, and then 4 times 2 root 5 is 8 root 5. And then in the denominator, well, when we multiplied that 10 minus 2 root 5 by its conjugate, then we get this form here, a minus b, a plus b, and that just equals a squared minus b squared. So if we take our a is equal to 10, or 10 squared, that's going to be 100, minus our b squared, which is 2 root 5, and 2 root 5 all squared, what's going to be 2 squared is 4 times root 5 all squared, which is just 5, so 4 times 5 is 20, so we get 100 minus 20, and that's going to equal 40 plus 8 root 5 over 80, and I'll just write it out this way because we've got our common denominator, 40 over 80 plus 8 root 5 over 80, and now we just need to put these fractions into their simplest form. So 40 over 80 is half, and 8 over 80 is 1 over 10, so then we're going to get plus 1 over 10 times root 5. So that's question 7, part 2.